Hello everyone, I am going to present my project on eye disease detection. So this project basically classifies the different eye disease from retinal images using machine learning and deploying it as a web application. So let's start with the dataset. So I have used this dataset, and this is the publicly available dataset from Kaggle, and this dataset contains different retinal images categorized in multiple files such as different eye disease. Here you can see the 4 category file: cataract, diabetic retinopathy, glaucoma, and normal. I'll show you the sample images of it. Here are multiple sample images, you can see that. And this, so I used this dataset to train my model and evaluate my model. Now we will move to the development part. So here is the development part. I have performed the entire training process on Google Colab. Firstly, I have cleaned my data through data preprocessing. Like, I take all the images and then resize them in the exact all the same size so that the AI can easily understand the data set. And after that, I split my data into 3 categories: train, validation, and test. So training phase is just like a textbook. AI studies these pictures over and over to learn how disease actually looks like. After that, the validation phase, while AI is learning, we put these pictures to see if it's just memorizing the picture or it's getting better. And testing phase, it's like the final exam. We are putting the new different image which AI have never seen before, and here we see how it works properly or not. Okay, so next move into the training part. We have used 3 models. So the first model I have used, that is efficient net B0. So it uses compound scaling, meaning it tries to balance how deep, wide, and high resolution the model is all at once. I have trained all the models in 2 phases. The first one is training phase and the second one is tuning phase. And there are multiple epochs. From this model, I get the lesser accuracy. This is 25.43% accuracy, and here you can see the confusion matrix. Basically, it shows then how much time AI is right and it got confused. Basically, it shows the correctness and incorrectness graph. And here you can see the accuracy line is going up and loss line is going down. That's not good for the model, because when they move together, then the model is healthy, otherwise not. So this is not the ideal model. And the second model is in Resonate 50 V2, the deep specialist. And basically how it works, it uses residual learning skip connections method, which allows the model to be extremely deep without losing information. And final accuracy is 89.01%. Here you can see the perfect confusion matrix which shows the results. And here you can see that loss and accuracy graphs are moved together. That's healthy for our dataset. And the third one is MobileNet V2 model. The speedrunner, how it works, it uses depth-wise separable convolution, which is a fancy way of saying it does much less math to process an image. But if you're building an app for an old smartphone that doesn't have much power, it will be useful for that, but not for our dataset. So the winner is ResNet 50 V2 model, because its deep architecture got the tiny medical details for the high stakes tasks like IDC's detection. The heavyweight ResNet performed much better than other models. Okay, so here's the training is complete. After training the model, I created a user-friendly interface using Flask in Visual Studio Code. Here you can see the folder structure of a project. Here's the models folder, which contains the project file downloaded from the Google Colab, and this is the environment, setup environment, and this is my app.eval file of this project, and there is the requirements.txt and utils.piv file. When I will run this GUI, so the GUI looks like this. You have to upload an image on it, and it will predict the actual disease, and it will give it as output. I can show you how it works. So here I am uploading the retinal image, and when I run deep analysis, it will detect glaucoma with accuracy score 99.8%. And here is the little description or recommendation of related disease. Okay, then if I want to apply a different image, like I'm putting the image of normal. Okay, so here we can see it it gives the output as a normal image. It is healthy image. Okay, so with the accuracy score 98.9%. So I have uploaded my entire project in Git repository. Here project should be well documented and accessible for all the users. So finally I have deployed my project as a live web application using Hugging Face Spaces, and this is the deployed link of my project. Here you can see that the iDisease AI dashboard. Here user can upload image and then the model will detect it in backend. It will give you the exact disease as an output. So this project demonstrates the how machine learning models converted into real world applications. So thank you for watching.